80% of the world's traded goods move by sea, crossing thousands of miles of wide, open water. But this traffic is not distributed evenly across the surface. Instead, the majority of these ships are concentrated into a few intensely clustered corridors. These narrow passages are known as maritime choke points, the physical bottlenecks of global logistics. While the scale of the global economy is vast, its survival depends on the security of these few miles of water. The Strait of Hormuz is a narrow gap between the desert coastlines of Iran and Oman. It dictates the world's energy exports. Shipping lanes are restricted to 3 kilometers wide in each direction, leaving little room for error. Every day, 20 million barrels of oil, 1/5 of total global consumption, are forced through this narrow passage. Land-based pipelines cannot replace this volume. Consequently, any interruption to this small corridor causes immediate instability across the global energy system. To overcome natural geographic limits, humans began excavating artificial passages directly through the land to link the oceans. The Suez Canal is the prime example of this engineering. It was carved through the Egyptian desert to connect the Mediterranean and the Red Sea. This map shows how the canal shortens the route from Asia to Europe by over 7,000 kilometers. Today, that shortcut carries 12% of all global trade. Excavating a trench through a continent changes the logic of global logistics, turning land into a highway for ships. The Panama Canal opened the Atlantic to the Pacific over a century ago, but as cargo vessels evolved into massive megaships, the original rocky excavation became a physical limit to growth. In 2016, a consortium led by Webuild completed a massive expansion, adding a new parallel lane designed for the largest ships in the world. This expansion created the Neo-Panamax vessel class. Cargo ships built the maximum physical dimensions of the new locks. These new lock chambers are massive engineering feats, 427 meters long, 55 meters wide, and over 18 meters deep. This hydraulic engineering system effectively doubled the overall capacity of the canal's infrastructure. Ship capacity jumped from a limit of 5,000 containers to over 12,600. TEUs, or 20-foot equivalent units, measure this container volume. This single corridor now links 1,900 ports across 170 countries, supporting 14,000 transits every year. Mastering these narrow maritime highways ensures that 6% of global trade avoids a physical bottleneck. Despite these engineering upgrades, the global maritime network functions as a sensitive circulatory system. When an engineered artery like the Suez Canal is blocked, the consequences are felt globally. In 2021, a single ship ran aground and wedged itself across the canal. This single physical failure halted billions of dollars in international trade. Because the global economy is so interconnected, a blockage in one engineered strait causes immediate economic disruption across the entire world. From the natural geography of the Strait of Malacca to the engineered locks of Panama, these corridors are the vital links in our global network. All these corridors serve a single purpose: to reduce distances, increase ship capacity, and secure the flow of trade. While diplomacy and defense focus on political stability, the work of builders and engineers provides the physical continuity that trade depends on. Expanding and maintaining these narrow maritime highways ensures the global economy can continue to function within the physical limits of our geography.